All right. Hello, class. I'm Andre, and so I did my semester project on matrices in computer science. So we touched a little bit about matrices in chapter 2. A matrix is just combination of like rows and columns. So the matrices can be any size, 2 by 3 or 3 by 2 or like 100 by 100. But yeah, it's just this is the matrix, the rows and the columns. And so we learned a little bit about matrices in chapter 2 and like a little bit more recently too, but they're very useful for many different things, mainly because they have all these operations. So like matrix addition, subtraction, we learned these, and matrix multiplication. And then there's scalar multiplication, which we didn't touch on, but it's like where you multiply all the elements in the matrix by just a constant. And then there's the transpose. We learned that like you make the rows of the matrix into columns. Inverse matrix is like when you have two matrices and then they multiply. When you do the matrix multiplication, they have the identity matrix. And then another operation is this called Gauss-Jordan elimination. And it's basically used for linear equations. So like here on the right, there's an example. You put like all the coefficients in the matrix and the solution, and then you have to do the Gauss-Jordan elimination, and that comes out with the values. So yeah, because of all these operations, it gives like many applications to matrices. So in computer science, some of the things you can use matrices for are to represent relations, which is what we've been doing more recently. And then machine learning, like image recognition, that's what matrices are used for as well. And data structures, because you can store like lots of data in the matrix and then perform algorithms and stuff on it. And then cryptography, we learned a little bit with modular arithmetic, but it can be used for matrices as well, and then graphics. So in my coding presentation, I did it for cryptography, and then I also did a little bit with graphics. So yeah, my first thing I want to show you guys is doing cryptography with matrices. So like say we have this message, meet me Monday. And so we use this matrix, it's the 3 by 3 matrix, but you could use any size, 4 by 4, 5 by 5. But since it's 3, you divide like all the letters into sections of 3. And so yeah, you put each number for the letter and divide it into 3. And then you do matrix multiplication, like each of these groups of 3, and you get these encrypted numbers. So now if you send these numbers to someone, and they know the encoded matrix, then they're able to decipher the matrix by just multiplying by the inverse matrix, which is over here. So yeah, these two matrices, they're inverses of each other. So when you it's the inverse because you'll see there the identity. When you do matrix multiplication, it creates the identity matrix. But yeah, so now you do the multiply the groups by the inverse, and then you'll receive the decoded ones. And so as you can see, these numbers match the original numbers. And yeah, there's the decryption done. And then the second, I guess I'll show you the program for this. Okay, so in the program, you need the matrix multiplication. So this is the method for that. You take 2 matrices and then make sure they're the appropriate size. And then it does the matrix multiplication and it returns the new matrix. Yeah, let's go ahead and run it. So part 1 of the program is encryption using matrices. So as you can see, here's the encryption matrix, which is matched from the slide. And then this is the inverse, so it's used for decryption. So yeah, first step, like I just did this part to show that the 2 matrices, when you do matrix multiplication, it comes out to this. show identity matrix. So that shows there the inverses of each other. But yeah, now let's actually do the encryption. So we're gonna do meet me Monday. And so first thing the program does is change all the letters into numbers. And now next we're gonna encrypt all the numbers. So we'll do the groups of three, first this three, then this three, then this three. So yeah, over here and in this part of the program, it takes the group of three and then it does the matrix multiplication with the encryption matrix. So this is the first group of three, second group of three, third, fourth, fifth. Do the matrix multiplication with all of these, and you get this output of encrypted numbers. So now you'll send these numbers to someone, and then they can use the inverse matrix to decrypt it. So next is the decrypting the numbers. So first you do the same thing we did with the encryption. You take the group of three, and another group of three, and then you do matrix multiplication once again with the decryption matrix. So you get a 3x1 matrix. You start out with a 3x1 matrix, and then you receive another 3x1 matrix. So yeah, all the groups of numbers after you do the decryption, it outputs this, the original message, meet me Monday. As you can see, the numbers, they match the original 5 group of numbers. So yeah, that's the encryption with the matrix. And now I did one more part since there's so many applications of the matrices. I did encryption and decryption, and then there's also graphics. So in case you, this is like the only reason that these two topics are related is by matrices, but otherwise they're separate. So just like now we're moving on to something else. I don't want to confuse you guys. So matrices can be applied to images as well. Basically, all the pixels in an image, they can be put into a matrix. And so as you can see, like this one is very pixely. That means that there's like each number in the matrix represents like a color. So the darker ones are closer to 1 and the lighter ones are like these higher numbers. But if you have like a much bigger matrix, you know, most images, they're like 1,000 pixels by 1,000 pixels. So then that's why it won't be so grainy like this. But anyways, as you can see, all these numbers in the matrix are basically representing this image. And so now that the image is represented by numbers in a matrix, you can easily manipulate it by just doing the operations I showed you before. So like if you want to rotate an image, you just transpose it. So as you can see here, you just make the rows into columns, and then you have what's it called? A rotated image. So that's how you rotate, just transpose the matrix. And then if you want to, like, for example, invert the color, I don't know if you guys have tried on your phone. Like there's you can press invert color and then it makes it like the color is inverted for maybe like colorblind people or something. So it's not really like I'll show you guys in the program. But yeah, when you invert, you just do scalar multiplication, multiply all the elements by -1, and then you have inverted the color. So now let's go back to the program. Yeah, this is part 2, manipulating the image using matrices. So I'm gonna press 5 to view the image, like the original image. As you can see here, it opens up the image. It's a picture of a dog. So now say we want to rotate the image, so transpose it, just press 1 and it opens up the image rotated. All we did was make all the columns in the matrix into rows, or like vice versa. So I can show you that in the code here. It's if you click choice 1, you get transpose matrix. And so the code to transpose the matrix is here. You just like switch all the rows and the columns. See just a few lines of code, and because it's in the matrix, you can easily do this manipulation. So Now we have a rotated image. We want to rotate it back to the original one. And now we have the normal image again. Now we say we want to invert the color of the matrix. So you just do scalar multiplication. Like I said, multiply every element in the matrix by -1. And now you get this inverted color. So yeah, like I mentioned before, you might have seen this on your phone when you press invert color and all the colors look like this. Yeah, it's just multiplying the pixels by -1, the values. So then it outputs this instead. So say now we want to reflect the image. So like, let me show you the image again. Say we want to reflect it. So now the dog, we want it to face the other way. Then you just gotta switch all the pixels on this side and put them on the right side, and all the pixels on the right, they get swapped on the left. So I will press reflect image, and here we go. Now the dog is facing the other way. So yeah, that's what you just done by, in this part of the code, reflect matrix. See, it's just swapping all the elements. And once again, see, just a few lines of code and it can be done like that because it's in the matrix. So yeah, that's the point I'm basically trying to get across to you, that by using matrices in computer science, everything is like, you can do it quickly. Whereas instead of just doing everything, doing like each pixel one at a time, you can just put the matrix, the pixels in the matrix and then do that. And finally, the last thing I want to show you is that you can stretch the image. So, well, actually first let me make the color back to normal. So multiply it by -1. Now we have the regular image, still reflected. Say we want to reflect it back again, you can just swap all the elements again and reflect it. All right, so finally, the last one is stretch the image. And it's basically what it's doing here. It's just taking each column of pixels and then moving and copying that column into a second column. So now instead of like, say the picture was like a 400 by 400 matrix, and now it's 800 by 400 because you just copied each column twice. So yeah, we can even stretch it again. And look, now it's even more stretched because you're copying the columns into that. But the one thing to notice is when you stretch the image, like if you zoom in, you'll see like it's not so clear because when you're stretching it, you're just copying the same pixel. It's so like the depth is just the same from one column to the other. You're not actually like, that's why when you have a 4K camera, like it's capturing more pixels instead of just making the image bigger. So yeah, that's the function, like how you can manipulate the image just by like transposing, multiplication, reflection, all just with the matrix.
Thank you. Very, very impressed presentation. It basically mentioned starting with metrics, operation, and also going into a different area like encryption and actually running a program, showing how the program work. And it's very interesting. I thought a lot of things. Like number one, if I'm the one interviewing at a San Jose company, I give you a 6-digit salary right away to begin with, because you're showing me the concept you learn. You're showing me some programming. You're showing me your understanding. Not only that, applying the knowledge in many different presentations. That is very good presentation.